This construction system uses interlocking, U-shaped panels made from fiber-reinforced concrete. Each panel is 2.4 meters long, and the sleeper version measures 2.4 by 0.0, 2 by 0.08 meters, weighing about 44 kilograms. It's been tested to meet Australian standards for structural loads, cyclones, fire, sound, and water resistance. Some panels come with built-in channels for plumbing and electrical services, which are added during the manufacturing process. Reinforcement can be included when needed, depending on the demands of the site. Everything connects without mortar. The dry-fit design locks panels together with grooves and tongues, so there's no waiting around for materials to cure, and bad weather doesn't slow things down. On-site work moves quickly. Builds that would normally take weeks can reach lockup in a matter of days. One example home had its structural shell finished in just 11 days. The concrete surface is smooth enough for cladding or plasterboard to go on directly, and the tight tolerances keep walls straight and clean. It works well for homes, commercial spaces, and retrofitting older buildings. The system replaces traditional blockwork, making construction up to 4 times faster and less dependent on highly skilled trades. The sleeper units are also used in retaining walls and foundations. Panels are delivered to site ready to go, and if pre-plumbed, they can reduce on-site service work by up to 70%. The tight seal between units keeps water out without the need for extra sealing materials. Already in use in New South Wales and South Australia, the system is expanding to the US and Canada. It's been picked up by industry groups and prefabrication networks, and a team of experienced builders is driving the growth across more regions. Is it possible to move entire buildings, roofs, walls, everything, without tearing them down? Using powerful hydraulic jacking systems, they can lift structures weighing hundreds of tons, inch by inch, with exact pressure control. Steel beams are slid under the foundation, supported by stacked towers of wood or steel to keep the building steady, while it's raised or rolled away. In some cases, they've lifted warehouse roofs over 18 feet to make room for new equipment inside. For projects that need new foundations, they dig out the space beneath while keeping everything above safely in place. To move a building from one location to another, they use transporters with multiple axles and steering systems that can handle tight turns and city streets. Their gear includes high-capacity jacks, thick steel beams, heavy-duty trailers, and control systems that keep everything level and secure from start to finish. They've been doing this work for over 50 years with a small, specialized team. Their reach covers the entire US from the Northeast to the Pacific coast. Every job starts with a detailed survey, measuring the building, checking the foundation, planning the route. Once that's done, they get permits, install equipment, and begin the lift. The move itself comes next, slow, steady, and heavily monitored. Then the structure is lowered into place and checked again for level and stability. The whole process can take a few days or stretch into weeks, depending on the size of the building and the challenges involved. Costs depend on weight, distance, foundation needs, and what it takes to clear the path, things like traffic signals or buried utilities. Their work includes moving a 430-ton public library in Connecticut, raising historic homes above flood zones, and relocating buildings that others would say are impossible to move, all without losing the original structure's form or function. This single-use formwork system is made for concrete walls, where the reinforcement runs straight through without breaks. It's available in several widths to fit different wall thicknesses, all with a standard height of 1 meter. Rebar goes right through a built-in glass fiber mesh. No need for drilling or extra prep. It's nailed to regular formwork using 3.1 by 65 millimeters aluminum nails, then stabilized with a wooden wedge in the center before pouring the concrete. Once the concrete is set, the formwork stays in place and creates a clean, intentional joint between sections. It's a smart option for phased construction or spots with tight reinforcement spacing, where working room is limited. Since there's no stripping or foaming involved, it cuts down on both time and hassle. The process is simple. Nail it in, thread the rebar, stabilize, and pour. That's it. No removal or follow-up needed after the concrete cures. Because it stays embedded, it keeps the rebar path uninterrupted while clearly marking out a break line between pours. It works especially well for projects like basement walls, lift shafts, retaining walls, or other below-ground structures, anywhere the job has to move quickly, or where labor is tight. It creates solid, reliable joints without extra steps or special tools. Weighing 5,600 tons and stretching 22 meters long by 11 meters wide, this concrete bridge wasn't built in place. It was put together off-site and slid into position in a single push. 5 powerful hydraulic jacks, each about 3.8 tons, moved it forward at roughly 9 meters per hour. The whole move took just 5.5 hours, wrapping up more than a day ahead of schedule. To get the site ready, crews took out 113 meters of rail and 188 sleepers, then dug out about 15,000 cubic meters of material, including layers of tough sandstone. Around 250 workers stayed on the job around the clock to finish the move and immediately start restoring the railway. Ballast was laid back down, tracks were reinstalled, and the embankment was rebuilt, keeping rail disruption to a bare minimum. Stone shouldn't bend, but these panels do. They look like solid marble or granite. Sleek, heavy, expensive. In reality, they're high-performance composites engineered for strength, flexibility, and minimal weight. Built in layers, these panels combine natural stone or advanced surface materials with a core of aluminum honeycomb and a sturdy backing. The result? Structural cladding that's up to 80% lighter than traditional slabs, but just as stunning. Depending on the configuration, panel thickness ranges from 5.5 to 50 millimeters, with a standard 25 millimeters panel weighing just 22 kilograms per square meter. Sizes can reach up to 150 by 300 centimeters, and the system is flexible enough to wrap around curves as tight as a 50 centimeters radius. The layers are bonded with high-strength adhesive, creating panels that are both strong and durable. Impact resistance is exceptionally high, about 60 times that of solid granite, and the panels maintain excellent structural rigidity. Over time, the adhesive bond actually strengthens, reaching up to 460 pounds per square inch. These panels are built to withstand harsh conditions, meeting Miami-Dade NOA standards for wind, water, and even missile impact. They also meet a wide range of fire safety certifications. Installation is clean and efficient, thanks to a patented clip and track system that avoids the need for mortar. The panels handle large sizes and curved shapes without compromising performance. Because they use significantly less stone than solid slabs and are much lighter, they're easier to transport and install, and they help reduce environmental impact. Manufactured in the US, UK, Australasia, and China, HyCOMB panels have been used in projects like Kensington Row in London and 321 Ocean Drive in Miami. They're a fit for everything from building facades and interior walls to furniture, bathrooms, and even vehicle interiors. Natural stone can be heavy, hard to work with, and slow down a project. This cladding system offers a smarter solution. It uses a thin layer, 8 to 10 millimeters, of real limestone, slate, granite, or sandstone, bonded to a 19 millimeters thick core made from aerated concrete. The full panel comes in at around 30 millimeters thick and weighs up to 50 kilograms per square meter, which cuts the usual weight of solid stone by more than half. Panels can reach up to 3.2 meters in length and 1.4 meters in width, covering large areas with fewer joints and cleaner lines. They attach using hidden ceramic disc anchors and clips fixed to a metal frame. That setup works well for ventilated facades and curtain wall systems, and it's just as effective indoors for decorative feature walls. It also meets Class E5 for impact resistance. Behind the panel, a ventilated cavity helps regulate temperature and reduce noise, while mineral wool insulation, types TCG032 and TCG035, adds another layer of energy efficiency. This system fits all kinds of projects: new builds, renovations, high-rises, or ground-level homes. Its size and strength support architectural details like tall vertical panels, recessed corners, spandrels, and soffits. Joints can be neatly mitered for a smooth, continuous look. A wide range of stone types and finishes are available, from polished to textured, including local and imported options. Because it's much lighter than traditional stone, it's easier to transport, lift, and install, without sacrificing the depth and realism of the real thing. It also stands up well to harsh weather and freeze-thaw conditions, while its flexible subframe can handle uneven surfaces. From exterior facades to interior walls, it delivers a solid, lasting finish with far less hassle. This modular manhole-based system changes how underground chambers are installed. Instead of pouring concrete on site, everything arrives ready to go, precast in the factory for speed and consistency. Sizes range from DN 1200 all the way up to DN 3600, with each version designed to handle the demands of modern drainage networks. The DN 1200 model has a 1.2 meters internal diameter and comes with a polypropylene liner that includes shaped channels and built-in pipe seals. The walls and floor are 15 centimeters thick, and it supports pipe diameters between 15 and 30 centimeters. Depending on the setup, it weighs between 1.5 and 2.7 tons and is lifted using 3 M24 sockets. Larger models, D, N1500, 1800, and 2100, are made entirely from solid concrete and use tongue and groove joints. They come with integrated rubber seals and can handle pipes from 15 to 1.2 meters. A simple clock system guides the placement of each inlet and outlet. Weights go from about 3.5 tons for DN 1500 up to 10.5 tons for DN 682100. These are moved using 3 M36 lifting sockets. The sealing system allows for slight misalignments during pipe connection, which helps keep the install process moving quickly. It works with PVC, twin wall, clay, concrete, and ductile iron pipes, and matching sealing strips are available for each size. Installation is quick. Place it on a compacted gravel bed, connect the pipes with seal lubricant, and stack the chamber rings. There's no waiting around for concrete to set. Everything fits cleanly, flows properly, and cuts down on time underground. Most installs wrap up in about 30 minutes, giving teams a faster, safer way to finish the job. Imagine getting a building delivered almost like furniture from a flat pack store, or even better, already assembled and ready to go. That's the idea behind modern modular steel construction. It's fast, efficient, and tough enough to handle just about anything the world throws at it. Every structure is planned using digital modeling tools and precision machinery to reduce waste and improve accuracy. The exterior can be finished with steel or composite panels, while the interiors include drywall, insulation, and fully integrated electrical and plumbing systems. These buildings meet seismic requirements and perform reliably in temperatures from -50 degrees Celsius to +50 degrees Celsius. Volumetric modules arrive fully assembled and are stacked quickly on site. Panelized systems arrive flat and are assembled piece by piece over a structural frame. This method also allows the buildings to be taken apart and moved if needed. The scale of production means DORCE can deliver thousands of units in a short time. All work follows international and regional standards, including ISO and BIM. With 4 decades of experience, DORCE runs Europe's largest facility for this type of steel production. They've completed full projects, designed to handover, in more than 60 countries. Volumetric construction is often used for housing in mid-rise buildings, worker accommodations, or urgent shelter needs. The units are finished in the factory and then placed on-site, ready for connection. Panelized construction is more flexible for transportation and setup, especially in hard-to-reach areas. Both systems help control costs and timelines while delivering consistent results. The process also has environmental advantages. Producing the parts off-site cuts down on excess materials and energy use. Insulation and integrated systems help manage energy more efficiently once the building is in use. This material starts with a simple but powerful idea. Take 2 stainless steel plates and connect them with a grid of ultra-thin tubes, then fuse everything together using high-temperature copper brazing at 1100 degrees Celsius. The result is a solid, engineered panel with serious performance. The tubes come in diameters from 16 to 140 millimeters, with walls as thin as 0.09 millimeters. Panel sizes go up to 12 meters long and 2 meters wide, and thickness ranges from 10 to 400 millimeters, depending on the need. For buildings, one common setup uses 51 millimeter tubes spaced about 100 per square meter, with overall slab thickness between 100 and 150 millimeters and weight from 31 to 108.6 kilograms per square meter. What makes it stand out is how much strength it packs without the bulk. Compared to flat steel, it's up to 7,350 times stiffer, while being 30 to 60% lighter than traditional steel concrete slabs. A full-size floor panel can handle the weight of 20 adults on stilts without sagging. A standard 150mm slab weighs around 7 pounds per square foot and supports roughly 60. Production doesn't rely on manual labor or messy job sites. Instead, everything happens in fully automated factories with robotic lines and AI-guided systems. One panel rolls off the line every 2 minutes. It's already being used in buildings, bridges, ships, aircraft, and wind turbines. In buildings, it replaces floors, walls, and beams, allowing spans up to 12 meters and fast construction. Ships built with it stay afloat even if flooded. Vehicle shells made from it weigh significantly less, improving efficiency. Wind turbines benefit from lighter, long-lasting blade panels. This material holds up for the long run. It resists environmental wear, stretches without snapping, and doesn't need concrete or scaffolding on site. It's also fully recyclable, leaving nothing behind. Steep roofs come with a tough problem: how to keep everything, soil, plants, and structure, secure on an incline. This modular grid system tackles that head-on. Each unit measures 540 by 54 centimeters, stands about 10 centimeters tall, and weighs roughly 2.1 kilograms. Made from high-density polyethylene with about 80% recycled content, the system holds strong against downward pressure, handling shear forces up to 8 kN per meter, or around 1,100 pounds per piece. You'll need just over 2.5 units per square meter to fully cover the surface. The setup starts with a root-resistant waterproof layer, followed by a thick fleece mat made from recycled fibers. This mat adds about 17 millimeters to the build and holds up to 12 liters of water per square meter, adding both protection and function. The grid is installed from the bottom up using a simple T-plug connector, then filled to slightly above the top edge. A custom substrate, usually a mix known as heather with lavender light, adds around 11 centimeters in depth. On top, drought-tolerant sedum plants, either as mats or plugs, complete the build. In total, the layers reach a height of 12 to 15 centimeters. When fully saturated, the system weighs about 155 kilograms per square meter and stores up to 64 litres of water per square metre. Once installed and compacted, it can support foot traffic, making it a practical option for walkways and reinforced rooftop green spaces. The grid's main job is to prevent everything from sliding downhill. It works best when installed from the eaves upward. Proper irrigation planning is key, especially since water tends to drain fast on slopes. On steeper roofs, above 35 degrees, extra structural support might be needed. This system has already proven itself on projects like the Van Dusen Botanical Garden and Canada Summer Games Park. No tools, no metal, no wasted time, just a clean, fast way to join solid timber. The X-Fix system comes in two versions, X-Fix C and X-Fix L. Both are made from strong beech or birch plywood. X-Fix C connects CLT panels at ceilings and walls using a dovetail wedge that pulls tight under shear and tension. X-Fix L works in corners and edges, L, T, or straight joints, leaving no hardware visible. Each connector can handle around 28 kN of tension or about 14 kN for the smaller C's versions. Fire resistance testing has been completed for X-Fix C, and independent labs, including Lignum Test Center, have verified mechanical performance. The system is designed for easy installation. CNC milled mortises and a mallet are all that's needed. As the wedge slides in, it locks and tightens in one go. No screws, no drilling, just friction and fit. Real-world tests show strong performance in bending and shear. In more demanding setups, like floor slabs under high moments, traditional glued splines still perform better, so combining systems can help. When the connectors reach their limits, failures tend to occur through shearing in the wood, not slipping or cracking at the joint. The system's strength lies in its speed and reusability. Elements can be joined and taken apart without damage, which supports smarter building practices and reduces waste. No metal means no thermal bridges, staining, or steel problems. And because the pieces stay hidden, the timber surface stays clean and uninterrupted. As long as the cuts are accurate and the wood stays dry, the system holds up. This system brings together Schüco's aluminium windows and sliding elements into one clean, modular setup. It's designed to keep things consistent, both in how everything fits together and how it looks. Add-ons include adjustable Venetian blinds, blackout roller shutters, weather-resistant textile screens, insect protection with vertical or pleated horizontal blinds, and safety features like integrated glass panels or rail balustrades. Threshold options cover everything from a simple 20mm sill to a level version with a built-in drainage system. All parts connect through the same mounting rails, keeping lines clean and surfaces flush. Everything is pre-assembled and tested at the factory, so when it shows up on site, the setup takes about 10 minutes. There's no need to juggle between different trades or rework plans on the spot. Every connection point is already sorted. Whether it's drainage, shading, or safety, it all clicks into place without surprises. The system keeps the look consistent across every component, with matching colors, hidden screws, and sharp, narrow sight lines that don't distract from the overall design. And if needs change down the line, it's easy to swap one module for another without redoing the whole setup. Instead of treating each window or door as a separate project, this approach ties everything into one structure. It's neat, flexible, and future-ready. The design earned an IF Design Award for good reason. It simplifies the work behind the scenes while keeping the result polished and precise. What it really does is take a complex process and smooth it out. It keeps installations quick, aesthetics sharp, and updates easy, giving architects and builders a smart, clean solution that holds up over time. Thermal performance and structural integrity take center stage in a system designed to prevent energy loss through concrete and steel junctions. It uses insulation cores, typically 6 to 12 centimeters thick, made of polystyrene, mineral wool, or foam glass. These units fit slab thicknesses between 16 and 28 centimeters, with options for adjustment. Depending on type and size, elements such as the MM, VXL, or MXL series manage shear forces from 12 kN up to more than 86 kN, and can also resist bending and axial loads. A certified service life of over 50 years is documented under ETA standards. Fire performance reaches REI 120 with the combi element, which combines a polystyrene center and mineral wool strips for added thermal and fire resistance. Other connectors in the range also meet fire classification standards and qualify for use in low-energy buildings. Thermal bridges are interrupted where interior and exterior structures meet, improving U values and reducing heat loss. Variants within the system meet a wide range of construction needs. The cantilever unit connects precast or poured concrete elements to the main structure, maintaining thermal separation. The FB unit is developed for steel-to-concrete junctions, using stainless steel spacers, wooden setting templates, and compression modules for installation. Installation is supported by modular parts, including compression and shear connectors that pass through the insulation without compromising force transmission. Available as split units for prefabricated sections, the system offers template guides and metal shims for precise on-site adjustments. Software tools support configuration for custom geometries and extended spans. This gravel grid system is designed to keep loose surfaces in place and functioning smoothly, even under heavy use. At its core is a honeycomb layout made from recycled or virgin plastic, available in depths of 30, 35, or 40 millimeters, with each 40 millimeters wide cell locking gravel into position. Depending on the version, it can handle from over 250 to more than 450 tons per square meter, enough to support cars, trucks, and constant foot traffic without shifting or sinking. A welded fabric layer underneath stops gravel from moving around and helps block weed growth. Water doesn't pool on the surface. It drains straight through into the ground below, helping prevent flooding and keeping paths dry. It also meets accessibility standards, so once filled, it stays stable enough for wheelchairs, prams, or walking aids. Everything used in the grid can be recycled, and many versions are made with up to 100% recycled plastic. Because the structure holds gravel tightly in place, it uses far less material than traditional loose-fill surfaces, saving over 60% in stone while keeping things tidy. Putting it in place is pretty direct. Remove the top layer of soil, lay a solid base with clean aggregate, clip the grid panels together with a small overlap, and fill with angular gravel between 6 and 20 millimeters. On slopes or in busy areas, adding stakes keeps everything secure. To keep it looking good, the surface just needs the occasional rake to top up where needed. It works well for driveways, parking areas, sloped paths, and access routes. Whether it's a steep incline or a flat front drive, the surface stays firm and level over time. With strong load support and reliable drainage, this grid system gives a clean, long-lasting finish without relying on concrete or asphalt. Three panel widths, a range of heights, and 36 possible combinations. That's the basic logic behind this smart system for creating rectangular openings in concrete. The setup works with slabs up to 25 centimeters thick and covers everything from small service penetrations under 0.05 square meters to larger openings over 0.25 square meters. On site, the panels click together to match the needed size. Then a wooden lid is nailed in place to hold it all steady during the pour. Once the concrete sets, the lid comes off and the box slides out, leaving a neat, accurate hole exactly where it needs to be. The panels themselves are likely made from a rigid, reusable material tough enough to hold up during pours, and light enough to move around without special equipment. Because they're modular, there's no need for custom cutting or measuring. Just pick the right pieces, assemble them, and go. The available panel heights are designed to match typical slab thicknesses like 150 mm, 20 or 30 centimeters. Next starts with a simple idea. Know exactly how strong concrete is, right where it sits, without breaking anything or waiting on lab results. This system uses piezoelectric sensors that pick up on tiny vibrations as concrete hardens. Those shifts in frequency get translated into real-time data about strength and temperature, and it's accurate within 95% of traditional lab tests across all kinds of cement mixes, including ones with fly ash, slag, or silica fume. There's no need for maturity curves or custom calibrations. It doesn't matter if the mix changes or the weather does. The setup includes small echo sensors, rechargeable sentry loggers with LTE, a charging cradle, and an online dashboard that tracks data for nearly a month. Installation is quick. Attach a sensor to rebar or formwork before the pour. As soon as the concrete goes in, the logger turns on and starts sending updates wirelessly to the dashboard. From any device, users can see how the concrete is doing, minute by minute, without touching it again. This kind of visibility means fewer delays. Crews can make calls faster, when to open a road, remove forms, or tension cables, without guessing or overbuilding. It also saves money. Skipping the lab work and cutting back on unnecessary cement can lower costs significantly, by up to 25% in some cases. And if plans change? The system keeps working. No recalibration, no rework. It keeps tracking strength and temperature accurately, even if the mix or schedule shifts. That makes it a smart, flexible solution for real-world jobs where conditions vary and timing matters. It turns concrete from a waiting game into a real-time process you can see, trust, and move on from with confidence. This underground chamber is made from medium-density polyethylene using rotational molding, giving it a solid, joint-free body that's designed to last. It measures around 57.5 to 60 centimeters across, stands between 60 and 62 centimeters tall, and has a neck opening of roughly 33.5 to 41.5 centimeters. Inside, it holds about 1 to 0.23 cubic meters, and weighs just under 10 kilograms with the lid on. There are 8 internal mounting plates, each round 23 by 18 to 26 by 18 centimeters, and the ports for cables can be customized from 2.5 to 11 centimeters in diameter using AGV adapters. It holds up in temperatures from -40 degrees Celsius to +60 degrees Celsius. The body is molded as one piece, avoiding weak spots from welding or seams. It comes with a screw-on lid that seals tightly with rubber and only opens with a specific key. Cable entry points are marked out ahead of time and can be drilled during setup, sealed with rubber adapters. No adhesives or welding needed. Reinforced ribs on the outside help it handle the pressure from soil and traffic. Inside, it can be set up to run cables straight through, split off, or turn at an angle depending on the layout. To install, it needs a 75 centimeters deep, 87.5 centimeters wide pit with a 15 centimeters sand layer at the bottom. It's backfilled with sand or soil. In wet areas, a concrete slab may be used to weigh it down, and in places with heavy foot traffic, a support ring and certified cover are recommended. At 30 by 60 centimeters and about 19 centimeters tall with its protective frame, this modular green roof tray comes ready to go. Pre-filled with drainage slots, a filter layer, soil, and a mix of sedum or perennials. It's made from fully recycled polypropylene, and includes recyclable side pieces. Each tray covers 1.92 square feet, works on flat or gently sloped surfaces, up to 20%, and holds plenty of water to help manage runoff and ease heat buildup on rooftops. There are two versions available, one for concrete roofs and one for lighter structures like wood or steel, making it flexible for different building types across Australia and New Zealand. What sets it apart is how it combines everything needed for a green roof: drainage, filtration, growing medium, and plants into one tray. That means faster installation and fewer separate materials to manage. The trays fit neatly next to each other, and once placed, the side belts are removed so the plants can spread and fill the gaps naturally. During shipping and setup, a protective belt holds the plants in place. Once installed, the trays still allow access to the roof layer beneath. They're also designed to hold steady in strong winds, especially useful in coastal zones. The plant mix can be adjusted based on regional climate, so it keeps thriving long after install. Sarnafil is a 1.8 mm thick, multi-layer waterproofing membrane designed for demanding roofing environments. It's made from a flexible polyolefin blend with added elastomer, giving it the flexibility to perform even in low temperatures and the ability to be welded securely with hot air. Its standout feature is a polyester fleece backing that contains special polymer fibers. When these fibers come into contact with water, they swell into a gel that seals small punctures, offering a built-in self-sealing response that protects the roof without needing immediate repair. The membrane has a matte gray surface and includes internal glass fiber reinforcement. The self-adhered version adds a glass fiber scrim and a factory-applied adhesive backing with a release liner. Both versions come in 2 meter by 10 meter rolls, with the standard weighing around 2.3 kilograms per square meter, and the self-adhered version slightly more at 2.3 kilograms per square meter, 6 kilograms per meter cub. It's designed to perform under pressure. It handles tensile loads up to 950 newtons per 50 millimeters, stretches at least 18% before breaking, and stays dimensionally stable over time. It can take hits from falling objects, resisting hard impacts up to 1 meter, and soft body impacts up to 3.5 meters. It remains flexible at temperatures as low as -50 degrees Celsius and holds strong under static loads of at least 20 kilograms. It also passes strict standards for water tightness, UV exposure, vapor diffusion, and chemical resistance. Installation ranges from -30 degrees Celsius to +60 degrees Celsius, with strong welds made along uncoated edges. It fits into the larger Sarnafil AT system. Thanks to its self-healing layer, it's especially well suited for places where roof damage could cause major disruptions, like data centers, archives, or labs. And testing shows it can hold up through the equivalent of 67 years of use. It doesn't just sit on top of old concrete, it bonds with it. This cement-based system blends right into the surface, forming a lasting connection that won't peel or flake away like traditional coatings. The formula is made from materials like calcium oxide, silicon dioxide, and aluminum oxide with smaller amounts of iron, magnesium, sulfur, potassium, sodium, and titanium compounds. The powder is very fine, about the texture of soft flour, and mixes with a cloudy white liquid to create the final product. Once applied, it dries quickly. In warm weather, it can be ready for a second coat in just 10 to 30 minutes. Cooler temperatures slow the process, and anything below 55 degrees Fahrenheit is best avoided. Once dry, the finish looks and feels like natural concrete, gray, solid, and reliable. It holds up well under sunlight and regular use, whether on a driveway, patio, sidewalk, or pool area. Because it becomes part of the concrete, it allows the surface to breathe, helping to prevent common problems like bubbling or cracking over time. There are 2 kit sizes available. One covers up to 400 square feet and comes in a 5-gallon bucket weighing about 24 pounds. A larger version for driveways covers up to 600 square feet and includes extra tools: a cleaner for oil spots, a protective sealer, a mixing bucket, and a strainer. Before using it, the surface needs to be cleaned and fully dried, usually overnight. Then the powder and liquid are combined, mixed with a drill and paddle for several minutes, left to rest, stirred again, and poured through a filter into a sprayer. Spraying takes a little patience and even strokes, but the result is a uniform surface that can take multiple coats. Measuring 48 by 96 inches and weighs about 70 pounds, just light enough for 2 people to move without a machine. Known as the EnduraMat, this mat is made to handle the pressure of serious equipment. Whether it's cranes, trucks, or tracked machinery, it spreads out the weight to protect the ground underneath. While the exact limit isn't listed, similar mats can take on point loads between 30 and 50 tons. It holds up well through repeated use and doesn't warp from sun or temperature swings. When the job's done, a quick rinse with a hose or pressure washer gets it clean and ready for storage. You can connect multiple mats using a two-way connector, letting you cover wider areas with a secure, joined surface. Layouts are easy to adjust depending on the site: straight lines, offset rows, or full coverage patterns. Construction crews use it to create stable ground for heavy machinery without tearing up the site. It's also laid down as a quick access road over grass, mud, or uneven ground, perfect for deliveries or emergency vehicles. At public events, it protects lawns and park spaces from damage caused by crowds and equipment. In utility work, it shields underground pipes and cables from the pressure above. Since it's temporary, there's no lasting impact once it's removed, and because it's reusable, it helps avoid the costs of permanent fixes or surface repairs. The EnduraMat is simple to handle, quick to install, and tough enough to keep showing up to work again and again. In concrete construction, especially with ribraft pod floors, the Podlock Spacer takes on a simple but important job: keeping the reinforcing steel exactly where it needs to be. It's made from UV-resistant plastic, strong enough to handle heavy loads and stay steady through the stress of a concrete pour. It fits rebar from 4 to 16 millimeters in diameter and holds it at set heights, keeping the concrete cover between 20 and 75 millimeters with very little margin for error. The spacer clips directly onto the edges of polystyrene pods and locks the rebar in place with built-in pins. No extra tools, no extra hassle. Its rounded edges are a thoughtful touch, helping to protect the steel from wear during setup. Once in place, it stays put, even when the concrete is vibrating during the pour. Builders usually space them every 50 centimeters, or follow whatever the engineering plans call for, so the support stays even across the whole floor. On site, it's known for saving time and avoiding mistakes. Since it clicks into place quickly and doesn't slide around, there's no need for wire ties or extra supports. Fewer parts, less mess, and less waste. Builders who've used it in the field say it holds up well and makes the job more efficient. Whether it's for a slab on ground, a suspended floor, or a precast panel, the Podlock Spacer helps keep the steel exactly where it belongs: stable, aligned, and ready for concrete. This expansion joint system is made from a tough copolymer reinforced with polyester, giving it the flexibility and thermal stability needed for demanding building conditions. It's tested to stretch up to 700% before breaking, handles temperatures as low as -57 degrees Celsius, and resists damage from UV exposure, harsh chemicals, and salt. It also holds strong under fire, withstanding direct torching up to 870 degrees Celsius. Water absorption is virtually zero, and its Shore A hardness measures 55 plus or -5. There are two options depending on movement requirements: FlamLINE 100 handles plus or minus 10 centimeters of horizontal movement, plus or minus 5 centimeters vertical, and plus or minus 5 centimeters shear. FlamLINE 240 increases that to plus or minus 250 millimeters horizontal, plus or minus 100 millimeters vertical, and plus or minus 100 millimeters shear. Both types move freely in 3 directions at once without breaking the seal. FlamLINE 100 measures 42 centimeters wide and weighs 1.2 kilograms per meter, while FlamLINE 240 is 56 centimeters wide at 2.45 kilograms per meter. The material is supplied in long rolls, either prefabricated or joined on site, and comes in black, grey, or yellow with a stripe at the gland. It's made to integrate directly into torch-applied waterproofing systems. When heated, the asphalt bonds securely into the joint's textured surface. It also works with cold adhesives and self-adhered membranes, giving installers flexibility based on project needs. You'll find this system used in places like roofs, plaza decks, tunnels, garages, walls, and even subgrade foundations. Its flat surface avoids creating puddles or trip hazards, and the seamless bonded installation cuts down on maintenance over time. For areas that see heavy foot or vehicle traffic, a protective top layer can be added. Mechanical concrete doesn't just fill potholes, it rethinks the road beneath your tires. Instead of relying on traditional aggregate or compacted soil for roadbeds, it uses a surprising upgrade: old tires. More specifically, it repurposes the sidewalls of steel-belted radial tires, turning them into confinement cylinders that hold crushed stone in place like never before. Here's how it works. The tread is removed from a tire, leaving a tough, circular ring of reinforced rubber. These open cylinders are placed in rows and filled with gravel or crushed stone. The result is a confined core that resists shifting, spreading, and settling. It's simple, scalable, and doesn't require special materials or heavy machinery to install. What makes it different is how the confinement works. When vehicles pass over traditional unbound stone, the load spreads, and the stone can push out or settle over time. But inside these tire rings, the stone is locked in place. It holds its shape under pressure, reduces deformation, and provides better load transfer with less long-term maintenance. Roads built with mechanical concrete have shown greater resistance to rutting and base failure, especially in areas with soft soils or heavy traffic. Regular asphalt gets a serious upgrade with a process that heats it to about 150 to 180 degree Fahrenheit, using infrared systems like the Street Heat SR60. Once softened, steel wire templates, usually in 2x2 fit sheets, are pressed into the surface using compactors to create patterns that look just like brick, stone, or slate. After it cools, the surface is coated with a 2-part water-based acrylic system. Street Bond SB120 is used for walkways and pedestrian zones, while SB150 is made to handle car traffic. The coating goes on at about 20 to 40 miles thick, depending on the area's needs. There are also add-on options: sealers that cut down heat from the sun or give the surface more gloss, and thermoplastic layers like Traffic Patterns XD or inlaid Duratherm, which help in busy, high-traffic areas. Known as stamped asphalt or street print, this technique takes plain pavement and makes it look like high-end brick or stone, without the high cost or long install time. It can mimic patterns like cobblestone or herringbone, giving streets, plazas, and driveways a clean, polished finish. And unlike concrete or traditional pavers, the asphalt underneath flexes with the seasons, so it holds up better against cracks, weeds, and freeze-thaw damage. One of the biggest advantages is speed. Crews can often finish a job in just a few hours, sometimes overnight. People can walk on it after 4 to 6 hours, and cars can drive on it after a day or two. That's a big win for places that can't afford long shutdowns. The surface holds up well over time and doesn't need much maintenance. When it does need a refresh, a quick reheat or recoat usually does the trick. The texture adds grip underfoot, and reflective options help reduce street temperatures. Creative Paving Solutions has been refining this process for over 20 years, bringing it to neighborhoods, intersections, and city streets across the country. Everything starts with precision in the smart automation in road building system. It brings together John Deere's Work Planner and Wirtgen's Smart Level Pro and Smart Pave into one streamlined setup. These tools take care of key tasks: setting milling depth, managing cross slopes, steering the screed, and adjusting its width, right from a single control screen. Thanks to GNSS receivers and RTK correction signals, the machines don't need extra gear to know exactly where they are and what to do. The system pulls data from digital terrain models and shows the milling area, volume, and depth details clearly, giving operators real-time updates as they work. Instead of relying on guesswork, crews use terrain models made with everyday surveying software. The work planner reads the current ground and the target surface and automatically guides the milling machines. When it's time to pave, 3 digital lines outline the direction and outer edges of the job, keeping everything on track and within tight tolerances. This setup works with the main crew and doesn't need extra specialists to get the job done right. The system also makes it easy to share data between machines in the same fleet or even with other contractors. Since the control systems are already part of the milling and paving machines, there's no extra setup needed. And for supervisors or planners without a surveying background, the map view keeps things easy to follow and gives a clear picture of how the project is laid out.